Welcome all.
So here your population, okay. Any kind of population you can take. Let me write population. Same thing like the last chapter. The population follows normal mu sigma square, and sigma is not known. And you have taken one sample, and sample here, sample notation we know, sample x. This we write x bar. This is the notation of sample. So here we have sample x1, x2, xn. Okay. Now this is your sample. You take a sample here. Let me write. So after taking the sample, you test. If you write the question here, so here you are checking IQ. There are so many here, and you have taken sample of what is in here 50. Okay, so 50 you have taken, and you have checked their IQ in 50. No time to check the IQ of each and everyone. There are a lot of students here. You've taken a sample of 50, and you have taken IQ, and the mean IQ they've given here. If it's a small sample, they can give you individually also. And the mean IQ they found for 50 students, and they found it 105. Now here also they've given sigma is known. Okay, let me take sigma is equal to 20. So you know sigma, you know n. So a sample of you can write 50 students, sample of 50 students, and their mean IQ was found to be, you can write 105. Okay, 50 I've written this one. Sigma is given 20. Let me write this way only. I don't have space here. Then test a hypothesis. Test a hypothesis to check whether the mean of all the students you can write. You have written here sample. Mean of all students is greater than 100 or not. So you are checking whether the mean of all is greater than 100 or not. Okay. So let me write our hypothesis here. This is the space available. So you are checking what you are checking. Checking for mu. Okay. On the basis of x bar, you are checking for mu. So now I can write h naught mu. This is notation. Okay. Which one is called alternative hypothesis? What is alternative to mu is 105. Here you are checking whether this is greater than 105 or not. This is called one-sided test. Okay. And remember, in confidence interval, we talked about pivotal quantity. Here we say test statistic. Okay. Let me write test statistic. The same thing. Test statistic. Okay. And test statistic here is x bar minus mu divided by sigma by square root of n. This you have to find. This is your test statistic, okay? So what are the name of hypothesis? H naught. H naught is the default one, mu is 105, testing. And the alternative hypothesis is one-sided, H1. This is the name. Always will write this way, remember. If you solve 50 problems, in 50 problems, you have to write this way. H naught will be mu is equal to something. H1 will be mu is greater than something, or mu is less than something, or mu is not equal to something. Here, greater than sign we have written. That means one-sided. This is called one-sided hypothesis. We want to know whether mu will be greater than 105 or not. We are not interested whether mu is less than 105 or not. We are not interested in that. So we have not written that one. Okay. We have
Sir?
tell me.
From the question, you under the hypothesis test, you said is greater than 100 or not.
Greater than or not?
No, you wrote 100, 100.
Okay. We'll take it 100. Okay. So let me change this to 100. Okay. This is 100. So you can test for 100. You can test for 105. You can test for 110. You can check for 1000 also. You can test for 1000 whether mu is 1000 or mu is greater than 1000. If you check this test, the test will fail because your sample mean is 105. If you write a number around your sample mean 100, 102, 110, 115, okay, there's a chance that you'll get a success. If you take a very big number like 1000 or 10,000, you can test it, but it will fail. Now, what is failing and passing? We'll do that. So we start this way. Under H naught, assuming that H naught is true, let me write here. Under H naught, we'll try to find the test statistic. Okay. Under H naught, that means you accept that this is true. We find the value of test statistic. X bar minus mu divided by sigma upon root n. Put everything here. X bar is 105. That is given. Mu we have accepted under H naught means we have accepted mu is 100. Sigma is given 20. Square root of 50. If you find this value is 1.768. This is 1.768. Now, like confidence in that chapter, the last chapter, we have here something called level of significance. Okay, level of significance. So, what is the level of significance here? At what level of significance you want to test your hypothesis? Okay. So you have to fix your margin before doing anything. Let's fix your margin. Margin say one-sided, so we will take from one side only because this is a one-sided test. How can you know it's a one-sided test? You have greater than or less than sign. If you get not equal to sign, that means both the sides you have to take. Now I should extend this one and join here so that, okay, let it be like this. Now this one is your rejection part, okay? This is the margin you have selected. And the other side, if you write, this is your accepted means green, okay? Oh, I have to close it. This is accepted, okay? And the margin we have given. Why we say margin, I will ask you later. Now you check where is your test statistic. So we have to write here what is your level of significance. You write your level of significance, okay? So with the level of significance, You can say 5%. 5% level of significance. It means level of significance, okay? With 5% level of significance, you are checking. If you take, this is LS, and you take standard normal table, this is standard normal, okay? Because this follows standard normal. So you have to see standard normal distribution and you have to write the number here. Check where is your TS line. If TS line is here, then it's accepted because this will be in the accepted one. So check whether where is your TS. TS is 1.768, right? And what is LS? 5%. See from the table, standard normal. 5% from right hand side. If you see, it should be 1 point. It should be 1 point. Remember, 1.96 or 1.6449. Vasantika, what is this is 5%. This side is 5%.
1.6449.
Okay, 1.6449. This is 95%. So that is equivalent to 95% one-sided confidence interval also you can say. So this you are saying 1.6449. Fine. So if it's 1.6449, 1.76 will come this side. So let me change this. Okay, I can cut this. That means it went to rejection region. Okay. Here. So let me write this one. Normally I write this. I'll send you my notes. You will see the difference between LS line and TS line. This is statistic. This is a testing. Okay. See, if you're testing, you found the statistic. Where it goes, it's in the acceptance region or it's in the rejection one. That is important. If it goes outside, okay, let me cut this one also. So if you write like this, because this number is greater, so if you write this value 1.768, 1.768, that is greater than 1.6449. This one is 1.6449. This number 1.6449. 1.7 is greater, that's why it's the right of this. Okay, this is your LS. Let me write once again. This is your LS, level of significance, and this is your TS, statistic. If statistic is to the right of LS, then it's rejected because we said that this the left hand side, your acceptance one. This one is acceptance. This is in rejection. Now my question is why you are rejecting if it goes here? Why you are rejecting here? It's a conceptual thing. Why you are rejecting if it goes this side? That is margin. Out of fear only we reject, because if you go by the test statistic, that is x bar minus mu divided by sigma by root n, what number you should get here? We are finding this value. What number you should get? Here we found we got 1.768. What are the possible values you can get? Because this follows standard normal, what will happen is we see the range of standard normal, it's minus infinity to infinity. You can get anywhere the value. It's another thing. If you find many times, here you will get more times. In the middle, around 0, you get more numbers. Then slowly it will decrease. Okay. The probability of extreme are very less, but still it can extend up to infinity and this side minus infinity. So you can get anywhere. A statistic you can get anywhere. Here, 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 here. We are keeping margin because we fear that extremes. Why you got an extreme? Any extreme is rejected in life. Okay. That way we reject. That's why there is a concept of error also. Type 1 error, type 2 error. We'll go to that. But out of fear, you can say we rejected. That's why we say margin. Out of fear, when I say, let's say some extreme thing, I'll post here. No, tomorrow's class will be at 3 a.m. Indian time. Okay. You will think that, okay, maybe it's an extreme thing, 3 a.m. Why is keeping class at 3 a.m. Indian time? Okay. So you might not join the class. If I ask next day, you will say, no, I thought by mistake you have written. Okay, that way. So with the fear that, okay, it's not true, we reject. If something is very extreme. Okay. Somebody says, no, I went to a place where the heights of the people were 7 feet. There are hundreds of 7 feet people. Or somebody says, I came from future. Okay. Don't know whether it's true or not. It might be true, it might not be true. But immediately we reject. No, how can somebody can come from future? Many they come to Earth and they claim that, they came from 2050 to 3000 years and all that time travel, they say. We immediately reject. Okay, I don't see those videos, and even if I saw once or twice, I never thought that is correct. Okay, that way, without testing, we say it's incorrect. Here also, because it went to extreme, it's rejected. So you have to define the norm. Okay, what is accepted. So in the exam, if you accepted it, it's not that everyone will accept it. Maybe somebody will write rejected it, he might get full marks. It depends on level of significance. If they will fix level of significance for you 5%, then answers will match. If they will not give level of significance 5%, then you can, if you have taken level of significance 5%, you kill this one. Somebody might take level of significance 10%, maybe not 10%. We should bring this one this side, say 1.96, 2.5%, and say for example another one is level of significance 2.5%. Okay. Let's use 2.5%. Then accept it. That is also possible. How it's possible? You take 2.5% to accept it. 2.5% means see, what will not change, what will change. Statistic will not change. Okay. But what will change here? Level of significance. We changed our norm. So that norm is no more 5% here. This is 2.5%. And with 2.5%, what happened? There is no such, okay, we'll do this way. This one also will make it green. Okay. So now what will happen? Now you draw another line. See, LS line will change because LS will come this side now. And this will be your, sorry, this will be your margin, this one. This one will be your margin now. This is the margin means, this is your rejection one. This will be your rejection one. Okay. So what will happen? Oh no. Yeah, we can do here. If you consider this portion will be your rejection region. So what will happen? We'll reject if something comes within that. But if you check, this is outside of that. So TS will remain the same. There is no change in TS, 1 point, whatever you've written, 768, 1.76 here. But now LS, our extreme is different. Our norm is different. Our norm is 1.96. So 1.96 is to the right. LS will decide what is your rejection, what is your acceptance. And now you check where is your statistic, whether it is less than LS or it is greater than LS. So here you have accepted because the statistics is in green. Green is accepted. Okay. The test statistic is not in the green one. Okay. That's why it's rejected. So my conclusion is accepted. Accepted means I've accepted H naught. Okay. I can't reject H naught. That is a real technical one. So I accepted H naught 100. Okay. Oh, again the problem today. At what level of significance? Level of significance is 5%. And the same thing I can write rejected. Rejected level of significance 10%. Okay. Oh, what percent? 2.5%. This is 2.5%. Yeah. Sorry, 2.5%. At level of significance 2.5%. 1.96. So the same rejected mu is 100. You accept or reject H naught. Rejected means you can write mu is greater than 100 here. Accepted this one, so you reject H naught. So you accept H naught or you reject H naught. Okay. You reject H naught or you can't reject H naught. On the basis of sample. On the basis of sample, you have to take a decision. Okay. So this is accepted or rejected. So in the exam, if nothing is given, by default, many take 5%. So you can also take 5%. That's fine. But if you want to really say, okay, something more than this without taking 5%, you have to find p-value. I'll tell you the p-value method. There are two methods. You can follow this way most of the time, 80-90% of the time, but you should know p-value also. Your p-value is this one. What is p-value? The formula for p-value is the probability that your statistic that is greater than statistic. This is p-value. You have to find p-value. P-value gives you the level, the extreme level. Okay, it gives you the norm actually. Norm means this way. Let's go to the next page. See what is norm here. Listen carefully. Okay, important. So, say in a school they conduct an exam. And one student got 7%. Tell me this guy is passed or not. You can say yes, 37%. You call someone and ask how much he got in the examination. And if he says, I got 37%, you will pass him or not. So what you will think before asking him whether he passed or not? What do you think? Vasantika, what do you think? Must he pass or not? Quick. Depends, right? In colleges, they take norm. Okay, in colleges, they take norm at what percentage they will take so that some students will pass. I remember when I joined the first job, what they did is they counted with every percentage starting from 35. Okay, counted at 35, they counted at 38, they counted at 40. They wanted to know. It depends on the norm. Okay, so you just can't fail 40% of students. So if you take norm 40%, then this guy failed because got less than 40%. It depends on the norm. Okay, if they will take 35% norm, the same student passed. So level of significance is very important. This is LS. This is LS type. Okay. This depend on what norm you are taking. If the norm is 40% at this level, this guy failed. Okay. If the norm is 35%, this guy got more marks, so passed. That way, p-value will tell you something, okay? At what level of significance it will be accepted, okay? That you will know if you find p-value. So I'll explain p-value and we'll do more the next